Welcome to my YouTube channel. I am Mosan Kastai from Government First Grade College, Kumta. In this video, I am going to explain you how to draw the Otto cycle. The first letters represents the section stroke on the PV diagram of the Otto cycle. Here, volume is represented on the x-axis and the pressure is represented on the y-axis. Already we have discussed in our previous video about the four strokes of the Otto engine. Let us represent the same four strokes on the PV diagram here. Here initially inlet valve opens and the piston moves in the forward direction. Therefore, here the piston moves in the forward direction at atmospheric pressure and room temperature. Therefore, the pressure is atmospheric pressure here. Pressure remains the same. T2A represents the section stroke here. The final temperature is T1. This is the room temperature. Final volume is V1. And it represents the section stroke. Here air and petrol vapor is introduced. Therefore, volume increases at atmospheric pressure and room temperature. And that is represents the operation stroke here. Here all the valves are closed and the piston moves in the backward direction here. Because the piston moves in the backward direction, due to the compression of the air and petrol vapor, pressure increases. The pressure increases and the volume decreases. Here, the volume of the cylinder decreases, but the pressure increases. A to B represents the compression stroke here. The final temperature is T2. The volume decreases up to V2. Therefore, AB represents the compression stroke. At the end of the compression, the sparking takes place, and due to the sparking, the temperature increases and also pressure increases. Here, due to the sparking, pressure increases, but the piston remains there only. Therefore, volume is same. That is, at constant volume, sparking takes place. Therefore, pressure inside the cylinder increases, but the volume remains same here. Therefore, B2C represents the combustion, D3 is the final temperature, V2 is the final value. That is, here during the combustion, the temperature increases from T2 to T3. BC represents the combustion. Now, and the third stroke is the working stroke. The piston moves in the backward direction. So, because the piston moves in the backward direction here, the volume is increasing. Due to the increase in volume, what happens? Pressure decreases. The volume increases and the pressure decreases here. Here C to D represents the working stroke. The temperature is T4. Therefore, this is the working stroke. Then in case of fourth stroke, there is an exhaust stroke. Outlet valve opens. That represents the valve exhaust here. Therefore, as the outlet valve opens, the pressure inside the cylinder decreases and the temperature also decreases. Therefore, at the same volume, the pressure during valve exhaust, temperature and pressure inside the cylinder decreases, but the volume remains same. Therefore, where the volume is V1, but D2A, the pressure decreases. Now, the cylinder is in the atmospheric pressure and room temperature. And after the valve exhaust, the piston moves in the backward direction. Here, the volume of the piston, so volume of the cylinder decreases at the atmospheric pressure and room temperature. So therefore A to E represents the exhaust stroke. Let me recapitulate the Otto cycle here. Volume is represented on the x-axis, pressure is represented on the y-axis. E to A represents the suction stroke because air and petrol vapor is introduced here. Due to the introduction of the fuel, volume increases at room temperature T1. So final volume is V1 and represents the suction stroke. And here the compression, gas compressed from A to B. Due to the compression, volume decreases, pressure increases. The V2 is the final volume. A to B represents the compression stroke. Here the compression is adiabatic compression. Here this is the combustion. At the end of the compression, combustion takes place. The temperature increases from T2 to T3. So this is the combustion. Then after the combustion, at high temperature and pressure, the piston moves in the backward direction. The gas expands adiabatically. With the expansion, volume increases, pressure decreases. C to D represents the working stroke, and the temperature changes from T3 to T4, and this working stroke is adiabatic process. And after the working stroke, outlet valve opens, the pressure reduces to atmospheric pressure and the volume remains same because the cylinder remains, the piston remains in its own position. Only the pressure is reduced to atmospheric pressure at room temperature. Then exhaust stroke. Now in case of the exhaust stroke, the piston moves in the backward direction. Here the volume of the cylinder decreases from A to E at atmospheric pressure and temperature. Thanks for watching. Don't forget to share and subscribe.